Yeah, so I'm Stephanie Avey. I believe I spoke at this meeting last year, and it is a pleasure to be back with you all and giving you a brief update on the HEMS tool. So I have been at AWC for about 4 years now, which is kind of crazy. And when I first got on, I started working with the HEMS tool and getting introduced to it and kind of the history of it, and working more on the research to operations end and improving the HEMS tool to serve the community as a whole. So next slide, please. Yeah, so if you're not already familiar with the Aviation Weather Center, we are one of 9 national centers within the National Weather Service, and we provide domestic and international aviation forecasts and warnings. And our vision is to be the trusted authority and leading innovator of aviation weather information. And one key way that we disseminate that information to both the public and to our users is through our website. That's www.aviationweather.gov, and we have a plethora of different tools and displays and just a ton of weather information specifically geared towards aviation users. And one of those products, next slide, is the Helicopter Emergency Medical Services tool, or our HEMS tool. And so if you're not already familiar with that tool, it is a web interface designed to show weather conditions for short distance and low altitude flights, which are common for the HEMS community. And in particular, we provide this information in a way that can be interpreted very quickly and effectively by non-weather experts. So they're making those quick decisions. Can they fly? Can they not fly? And so the idea is that they can go to the HEMS tool, get everything they would need for those flights very quickly and make those decisions. So one of the most critical weather parameters for these HEMS pilots and low altitude flights in general is cloud ceiling and surface visibility. So a focus over the past few years in particular has been enhancing this capability. We actually provide a gridded cloud ceiling and visibility product on the HEMS tool. And what this does is this interpolates information between observation points where we don't have observations, so that the user can get an idea of what's occurring in those areas where there's no observations available. Next slide, please. Yeah, so I think last year when I was presenting to this group, I was saying, hey, guess what? We have some changes coming up, and this was based on a multi-year effort. We were funded by the FAA's Aviation Weather Research Program to enhance the ceiling and visibility capabilities because we know they are so critical for this community, and quick changes in IFR to LIFR and various conditions can be very critical and cause safety issues. So we really wanted to make sure that we're putting the best ceiling and visibility information out there. And so we actually ended up going forward with a updated ceiling and visibility analysis that we now have on this page. It updates every 15 minutes and it provides that gridded information in between observation points. We also added hourly forecasts of ceiling and visibility information, and these go out to 6 hours. This wasn't something that was available before that. And then because this whole process involved a lot of user feedback and assessments, we actually ended up making a few user interface changes just based on what the users wanted and liked and how to make it more intuitive for them. So we updated the time slider and the configurations menu. So if you're familiar with the HEMS tool and you're already using it quite a bit, this is probably old news to you. These changes came out at the end of last March, and so they've been around for about a year now. And if you click on the slide quick, I just want to make an important note that we're no longer updating the current HEMS paradigm. I think that's really important to inform everyone that we're actually moving in a new direction. And I've highlighted this and mentioned this in the past, but we really want to push that forward. So Rex, if you continue to the next slide. We're looking at how do we evolve HEMS for the future? How do we continue to meet the needs of that community, but also the other users that are using it? So if you click to the next slide, this will give you a sense of all the different users, thanks to Rex, who've gotten the word out on the HEMS tool, and they're starting to use it as kind of their go-to for that low altitude weather information that they want. And so there's just a wide range of users, and they're all very interested in what's happening below 500 feet, below 1,000 feet. So we want to start incorporating capabilities and products that will serve their needs as well. So next slide. So yeah, the thing, when we started thinking about this and how do we move forward, and really this idea of having a web page at AWC that's more consistent across the board and more user friendly, and we were getting asked by the HEMS users for certain products and information and capabilities that we already had available in one of our products, and that product, that tool is the graphical forecast for aviation. And so this product in particular provides both forecast information and observation information back 16 hours and into the future for 16 hours for the forecast information. And it has a lot more information than what you're going to get from the HEMS tool. It's not just for low altitude flyers. It's actually geared towards general aviation users. And the idea is that they can go to this page, they can get all the pertinent weather information that they would need to self-brief for a flight that day. And so it really made sense to us to, how can we take all the great things that we have in HEMS and sort of build it into the GFA so that the users are getting the best of both worlds. And so integrating HEMS into the GFA LA is basically, is kind of the next step. And so we are going forward with that, and it's actually going to be called the GFA LA. It doesn't have the fun ring to it that HEMS does, but we'll work on that. And LA essentially stands for low altitude. So you will be able to click on a tab specifically for the low altitude version of the GFA, and this is going to give you everything that you know and love about the HEMS tool, geared towards those low altitude needs, but it's going to have a different look and feel, and the capabilities that we come to like and the users tend to like out of the GFA product. A few of those things that are there now that will obviously be incorporated are higher resolution winds below 1,000 feet. We get asked for that a lot. Winds are very critical for low altitude flyers. And additional forecast information, right now is kind of limited in the HEMS tool, but you're going to be looking at clouds with layer information. So beyond CNV, you're going to get an idea of where's the scattered cloud layer. What's the base of that? Where are the tops of the clouds so that I know if I can fly above them or whatnot. Precip and weather information directly from the local forecast offices out of the NDFD. So that will be on that product. And then of course turbulence and wind shear. So low level wind shear will be provided as well. And so if you have not yet been introduced to GFA LA or to the GFA, I encourage you to check it out. Just www.aviationweather.gov/GFA, just to give you a general sense of what's all on there and what you can anticipate when we transition to GFA LA. Next slide, please. Yeah, so those are the capabilities that are currently in the GFA that we're going to incorporate, but we're also looking at what specifically can we incorporate into the GFA LA to make it better. And one of those things that we get asked for time and time again is more observations. Right now we are showing operationally on our operational web pages the METAR observations because they are ASTA stations that are calibrated and they're constantly updated and making sure that they're in working order, and so that's what we're showing for observations. But we know that the widespread network is not enough for our low altitude flyers. So we were funded last year by the Aviation Weather Research Program to look at how we could incorporate mesonet observations in a safe way. So we know that this observation data set can be quite varied. It can be AWA stations, it can be DOT stations, but it could also include backyard weather stations. And so we need to be able to let the user know so that they understand exactly what type of observation they're looking at and how they can use that observation to make their decision. So we are actually developing a quality control of that information. Like I said, we just really want to make sure that we're putting the best data out there. If our users are looking at it, we have to ensure that it is good quality data. And so part of that QC is focusing on the temperature, the dew point, and the winds. This data set from the MATIS data set is a ton of observation information, not a ton of C&V information, but we know that users can sort of infer temperature, or they can infer visibility based on the temperature and the dew point depression from that. And of course, winds. Winds are hugely important, especially as you get into some of those dense urban areas. And so we're starting to look at those variables in particular and how we can get those on the display. And then we're also, asking ourselves, what are the thresholds that are important? So we want to make sure as we get close to those thresholds that helicopter users are saying, yeah, I can fly, no, I can't fly, that we're not, misleading them. So we have to make sure that that information, those observations that are hitting those thresholds is as best quality as it can be, most accurate as it can be for those users. So on the right, you just kind of get an example. It might be kind of hard to see on the small screen, but this is centered over DC, and so you'll see DCA Airport there. It's the one observation in black. That is the one METAR station that would show up on this display. So if you go to the operational page and you zoom into this level, that's all you're going to see. However, if you pull in the METASOBs or the Mesonet stations, that's everything in green. So yeah, if we start showing these, you're going to get a lot more information. Just the wind information there could be very useful for those low-level flyers. And actually, we have the one place that you can pull these observations up right now. They are not QC'd. I do want to put that out there, as we're still developing that, is on our testbed HEMS tool. And that website is right there down below. It's just testbed right in front of aviationweather.gov/HEMST. So you can check that out if you want to. So next page, or next slide, please. Yeah, and another really cool thing that we're excited to incorporate into the GFA-LA framework is a flight path tool. So right now, if you use the GFA or if you use the HEMS tool, you can actually type in points and get sort of a flight path in a pink line. It'll tell you, just to give you a general sense of what's happening along that path line. And then what we're hoping to build in and we're planning to build in is a flight path tool. So this will actually give you a 3D cross-section of information along that path. And so the example on the left shows a prototype of how that might look for clouds. So you're going to have a vertical profile of the clouds that you can expect as you're flying along, and then right below that the TAF information at sites, obviously, that have TAF information. We're also hoping to include icing information in a 3D format like this, and as well as turbulence and winds. So this will be really cool once we get that capability in there as well. So next page, or next slide. Yeah, so kind of the initial motivation behind this merge and behind bringing these products together is this idea to make our website more user-friendly, more user-intuitive, and part of that is consistency across our products. Right now we have a lot of different products. They might be hard to find. It's not super intuitive, and so we really want to build our website to be more user-friendly, just to have a more kind of current look to it, more modern look to it. And the idea that everything you don't have to like dig through to find a product that you want. It's just going to be very intuitive. And so we're building this capability to have a better website, a website interface. The GFA LA will be a part of that. And then another big thing that will come out of this is a more user-friendly or a more mobile-friendly interface. So you'll be able to pull it up on your tablet or your cell phone before you hop into the cockpit, or when you're on the ground and you're getting ready to take off, you'll be able to pull it up on your phone. We don't have a weather app. That's not something that we can provide, but we can make our site more mobile friendly for our users. So we're really excited about that as well. And so these updates, these capabilities are a few years down the road, but the GFA-LA is actually slated to be internally prototyped by this summer, so we can start looking at it internally, and then we hope to get it in sort of a beta interface for users to start looking at it by next spring. So which takes me to the next slide. Yeah, and as always, when we're updating a product or releasing a new product or making changes, we really know that user input is extremely critical. We need to get their understanding of it. We need to know, we're meteorologists and developers, so we're putting the information out there how we think it should be seen. But if the user doesn't understand that, then that's really not doing any good. So We are planning to do a full evaluation of the new GFALA. And the goal of that is to really, to see the usability and the utility of it. How does it compare to the HEMS tool? Is it, more user-friendly for you? Do you like it? Do you not like it? What is good? What is bad? And we do this by working with the FAA's Aviation Weather Demonstration and Evaluation Services Group, or AUDI for short, and they are our human factor specialists. So they actually will sit down with the users, get the product in front of them, have them interact with it and say, hey, what do you think about this? Tell me what your thought process is for this. Tell me how you would find this. And it really helps us pull out that critical feedback to move that product forward. So we're crossing our fingers that we're going to be able to have an in-person experiment in the spring of 2020, so around, a little bit over a year from now. But we do, we've spent the last year in this virtual realm, and we've done an evaluation in the virtual. We're working on doing another evaluation this summer in the virtual. And so we're confident that we can incorporate virtual components even as we go back to in-person. And I think this will be really critical especially for our pilots. I tell Rex all the time, like, we need more pilots. We need more pilots. We need their feedback. So please, get them in contact with me. How can we get them in front of the product before we go operational with it? And so by having these virtual components, we really hope that we can reach the wider helicopter community, you all, whoever you're connected with that can give us feedback. So think of that. If you want to get involved, please email myself or email Rex. And even if you just want to email me today, and I'll get you on a spreadsheet, and then I'll reach out to you when we actually get around to doing this evaluation. But I think it's going to be really, really important as we move forward to get, the direct user feedback, or anybody who's using the HEMS tool and can provide that critical input. So please, please, please reach out. Next slide, please. Yeah, so everything, that's kind of the near-term goals, but of course we're always thinking what's next. How is the NAS evolving in the next 20 to 30 years? And the obvious answer there is drones. It's UAS. It's unmanned aerial flights. And so how can we develop our products? How can we evolve the GFALA to meet the needs of those users as well? And so that's something that we're constantly thinking about, this idea of having just really dense observation networks in cities and urban areas, and just how much information we can provide on our webpage. So that's something we're looking forward to. We're excited how the technology is evolving and how we can constantly or continue to meet the needs of the NAS and keep it safe. And I'm sure Mateus is going to touch on this as well. And I know Rex said he's going to also kind of speak towards this as well later. So I will just get you thinking about that, and I think that's all I have. So next slide. Yep, so that was all I have. That's my email address if you'd like to reach out to me or Rex, and he can get you in touch with me as well. And thank you very much.
Thank you, Stephanie. Greatly appreciate that information. And I've been involved with the HEMS tool since we partnered with NCAR, UCAR, RAL back in 2006 when I was with the National EMS Pilots Association. It's amazing to see where this tool has come from and where it's at now, and I'm just encouraged to see where it's headed and can't wait to see the next iteration. So very appreciative of all the assistance from NOAA and the Aviation Weather Center, and all the folks there have done a fantastic job with that. Highly recommend, if you haven't checked out the tool, that you take a look at it. We are always looking for input. If you go to the tool, there is a place in the upper right-hand corner to give feedback. Always looking for feedback. They're very responsive when you provide feedback. If you have a suggestion, it gets into the system very quickly. Encourage helicopter pilots to participate. If you have helicopter pilots, bring them in for this next go around. It was very, very useful in getting pilots involved in the last evaluation and testing. It was some phenomenally good information came out of that. I will open it up to the floor at this point for any questions. If you have a question, we have a fair amount of people online, but I think we'd be able to do this. So please go ahead and unmute and ask a question to either Stephanie or myself if you have one.
This is Matthias. Quick question. I typed it in the chat room too. I thought you might want to do it that way. But a question for Stephanie. You mentioned that there will be higher resolution winds available in the GFA low altitude below 1,000 feet. And I'm kind of wondering what wind information will you provide there? Is that coming from the HER runs?
So right now, for the GFA, we're actually using RAP, and so it's interpolated below 1,000 feet at the different levels. But yeah, as we build forward, we're actually, looking at using HER or more higher resolution models in the future. So definitely, as more layers get added and as they move towards, the Rufus and whatnot, then we'll have hopefully more interpolated winds at different levels. But yes, that's where it's coming from.
Hey, Stephanie, this is Joshua. Very good presentation. I just wanted to note that the testbed HEMS is still password protected. So I know you said with the MATIS OBS, I think some of the folks on the line probably have access to that as targeted users. So I'm not sure if we're looking for feedback on the MATIS OBS at this point, or if that's more of the GFA LA step. So
Right.
maybe an opportunity to clarify what
Yeah, no, you're exactly right. So those they are on the testbed version of the HEMS tool, which is now password protected. It was open to anyone as we were getting feedback prior to our last upgrade to the HEMS tool. Like I mentioned, we're not really making any updates to the HEMS tool. We're not, as we work towards the GFALA. That is just an example of how we did incorporate MATIS observations into that testbed version, but they have not been QC'd. So that was something, the work that we're doing now is in the background of the QC, and that will be incorporated into the GFALA. So it is different. It's not what I maybe should have clarified that, or maybe I shouldn't have even mentioned it. But if you are using the testbed version of the HEMS tool, that's one place where you can actually get those observations, but they're not QC'd.
And then it looks like someone did type another question about the nav database. I don't know if you can see the question, Stephanie.
Yeah, it's me. For the navigation data and sound from the helicopters. And what I can understand is the flight path tool is a navigation database to calculate the route. Because I think we are speaking about VFR flights, no?
And you're coming in pretty broken there. I'm going to go ahead and read the question. Does the flight path tool use a nav database to calculate the route? Stephanie?
Yeah, so right now, you just type in points, so your nav points, and then it just draws a line. The actual flight path tool, I don't know about calculating a route. Like, I think you would have to put in the endpoints to get where you want to be or where you want to see the line. So where you want to get the information along that route. Hopefully that makes sense.
Okay, thank you.
Thank you. All right. Any other questions on the HEMS weather tool or anything that the Aviation Weather Center or Stephanie has showed today? Like I said, we're continuing to work with NOAA and the Aviation Weather Center as the U.S. Helicopter Safety Team. With the Infrastructure Working Group, we meet basically once a month. Stephanie's been a part of those calls for quite some time. So constantly looking to improve and get this out to more people. And as Stephanie said, we've actually found a huge interface now from other people that fly at low altitude. So the drone community have discovered this tool, as well as several other folks. The one that was the most excited that they found this was the people that fly balloons. They were very, very happy that they found this tool. So if you can help advertise the tool and get it into people's hands in general aviation that may not know it exists, that's great. If you have any questions, by all means, ask either myself or Stephanie. We're more than happy to help get the information in the hands of people that might be interested in it. I do see Dan Beater made a comment. The nav database includes VORs, fixes airports, but also allows the user to enter latitude and longitude points. So Dan's also works with Stephanie at the Aviation Weather Center.
Yeah, Dan is the web guru, so he would know more about that than
Yes.
I. So thank you, Dan. Thanks for clarifying.